A few years ago I built this computer arm for my CNC router, but as you can see now it's not feeling so well, sagged quite a bit. So before I get a critical failure, I'm going to rebuild it now from steel. But the interesting part is this wooden and hybrid with metal mechanism failed in a way I did not expect. Behind every bolt here is a steel bushing pressed into the wooden parts. And I always thought over time they maybe pressed themselves further into the wood, creating some wiggle room and causing the sagging. But the actual cause is more in this part and this area here. You can see a gap formed here which didn't on the bottom. And that's because there's quite a significant force constantly pulling on here and deformed the wood. And on top, this part also looks a bit deformed down from, the significant force. And the new design is basically the same as this one, just made for metal. So it can reuse every bolt, but not the springs. They currently support the weight for lifting it up and down a bit. There I now use gas springs, much better suited for this application. So yeah, here the design is. It's the same kind of parallelogram mechanism with the same overall dimensions, but now using square metal tubing for the arms, and all the brackets get welded together from 4mm steel. A perfect job for the laser cutter. That was 5 minutes of cutting time. These 4mm parts come off the laser almost burr-free, almost. So I go over all edges really quick with the angle grinder before proceeding. The holes are all slightly undersized, because although they are all fairly precise, I wanted them a bit better for this application, so I made them 0.5 millimeter smaller than the target and can now nicely open them up with a step drill. $10mm for the M10 stuff, obviously. 12mm for the M12 stuff. Nice! Then I've prepped all the weld areas and now give everything a nice clean with acetone, and then it's ready for welding. I'm starting with those parts, welding them to the side, and to help me with the hole alignment and distance, I made some spacer bushings that are the width of the middle plate. Only got lock nuts on hand, but now this is aligned and spaced correctly. Should fit on here. Looks good and can be welded together. I'm gonna laser weld everything, obviously, and first problem already, to nobody's surprise, weld distortion. The tubing that goes in here is 40mm square tubing, so I already made the plate on the bottom here 40.5, as well as the spacer. But now, after welding and distortion, but if I apply some heat in the middle here on the back, that should bend or distort it straight again. Interestingly, that didn't work and actually made it worse. Really weird, but I think I know what I did wrong. This is 4mm plate and I ran the 3mm settings with the laser, which penetrates about 3mm deep into the material. But when I try to pull through the heat shrinkage, the heat needs to be basically on the surface to be most effective. But if the heat is 3mm deep in the material, as you can also see from the other side, that pull is more even, or in this case, actually on the wrong side. So I should run the same beads, or maybe somewhere in between, with settings that make much less penetration. So let's try the 1mm settings. The shape doesn't look much different than before, but from the color you can see that there's definitely more heat inside the weld bead, not the material. And now the numbers also tell me this worked. Having learned this, I could do the same for the next part. Now just grind away all that crap and move on. I could have also tacked them in place and then kind of bent them outwards intentionally so that the weld distortion pulls them in straight again, but I'm not experienced enough to guess that right. Next, the pieces that mount to the machine cabinet going together like this. Here I'm gonna try the pre-bending and slightly hammer this out of square. If it's now square again, the time lapse should look good. Oh, it actually overbent again. Wow. So now I just use the force of the vise to bend it square again. And that looks pretty good. Then I fully welded this side because this doesn't affect the squareness anymore. There it's cleaned up and rounded over. Next come all the little pieces with the help of a threaded rod. I got the first bits spaced apart correctly and clamped together so they fit on this first part and can be welded on. Alright, tacked in place, I will now weld the outsides, then bend the parts open again a bit so the fillet will then pull it back straight. That was too much pre-bend. Hammer it is. Now I've got the next parts clamped in there again, so they have the correct spacing and alignment to weld to this part. Parts are welded up, and that's how they assemble. Just imagine the rod would be a bolt in the end. Nice. And even though if the spacing of the two parts I just welded on wasn't perfect, and in fact it isn't, doesn't matter, only one of the pairs will contact each other. There's a little gap, doesn't matter, works just fine. I'm doing the same for the other two parts, and that's the whole welding of this project. By the way, if I would have a sheet metal brake, then all of this could have been done with 0 welds and just bends. But also bending 4mm stuff is no easy task. Next now, the square tubing for the parallelogram mechanism. I cut 2 pieces to length and took off the corners, which I later need for clearance. Now all that's necessary is lay out the holes, drill them, and that's all. For accurate and round holes in this thin wall tubing, what works great with my current tooling is to first spot it, then drill all the way through with a small drill bit, followed with a bigger one, and then go to the step drill. There, accurate round holes. Now, just a step drill is also capable of doing that in thin material, but it's not long enough to reach the other side in this case. So first going in with a normal drill bit, nicely transferred the hole position to the other side and ensures both holes line up. This hole will get a carriage bolt, so I need to file it square. Good. and I tacked it in place so it will never come loose. From this hole to this hole is where the gas springs mount, and the mounting bolt here double functions as an end stop. So next, the gas springs. I've done some calculations to choose the springs with the right strength, because with the computer setup being mounted here weighing about 10 kilograms, that resulted in two 300 Newton springs. That's a bit more than necessary. That could support more weight than 10 kilograms in this orientation, but the calculations neglected friction, so we'll see. First of all, 300 Newton is a lot, about 30 kilograms, so it takes a lot to compress those. And they need to be mounted in an already slightly compressed state. That will be fun. Fortunately, these clamps are shaped like this underneath the pads, so I should be able to rather safely squeeze them together. But now I can't get the bolt in. Inserting the bolts first. No, don't put your fingers there. That's exactly where the pinch point is. All right, bolt is in. So lucky. Clamp is out. Feels good. That's a much better way. Yeah, this definitely feels like more than 10 kilos. But we know if it works when the computer is mounted. Before I take it apart, this is before. Let's hope that after is better. On the old mount, you can now see just how much this piece is bent and actually starting to crack here. In the beginning, this base bracket was also just screwed to the leg, but eventually started twisting, which is why I had to add these dowels to prevent this. The new base bracket screws to the leg from here, and that will eliminate any kind of twisting and is just much more solid. That's solid. Okay, fully loaded again. How will the arm do? Not bad. It can support quite a bit more weight now. Those are the internal dampeners, I guess, from the gas springs. Hey, I mean, that's great. But there's a slight oversight with this clamping bracket here. There shouldn't be a collision. Need to make a little bit of a cutout here to fix. And beautiful. That's everything working, so I can take it apart again and give it some paint. Couple days later, paint is dry, so final assembly. The bolts are obviously not tight and a bit long, but I needed to use those to have the smooth shank all the way through, and the stick-out doesn't matter here. Down here I won't let it rest paint on paint, but put a brass washer in between as a friction element, plus grease. Again, the bolt is not tight, and unfortunately the smooth shank here isn't long enough, so it's resting on the threads, but since the spacing of the hinge parts is big, it doesn't matter too much. Oh yeah, that is significantly stronger than the wooden version. much safer way. Fully assemble again. I also changed it to 300 Newton springs to 200 Newton springs. And now that is just perfect. Just strong enough to support the entire weight all the time, and it doesn't lift up constantly. So when I'm at the desired height, I lock it, then it's pretty stable there. Awesome. So now the comparison before and after. Yeah, that's much better. Still not perfect, but a lot better. There's still a tiny bit of play in every joint, especially where there are just threads. The only way to really eliminate that is how I did it for my camera arm. There I used precision ground shoulder bolts everywhere and precise bushings in every joint. This has zero play, but that's totally overkill for this application. Tiny bit of play is totally fine. In fact, it doesn't matter at all.